Hello all, welcome to IntuiTronix. Today we'll be discussing about the power dissipation in the basic components of electronics, that is resistor, capacitor and an inductor. So let us start with the expression for power dissipation in any component. Suppose you have a component here with the current IFT flowing through it, and suppose it has a potential difference of V of t. The power dissipated in the component is given by 1 by t integral 0 to t V of t I of t dt, where t is the time period of the signal. Now let us see the power dissipation in a resistor. Suppose you have a resistor R with a current IFT flowing through it. Then the potential difference across the resistor V of t can be written as V of t equal to I of t into R. Now, if you suppose I of t equal to I0 sine of omega t, then V of t becomes the resistance multiplied by the current. Using these two expressions, we can find the power dissipated in a resistor. The power dissipated equal to 1 over t in the integral 0 to t the voltage, which is R I naught sine of omega t, into the current I0 sine of omega t dt, which is equal to 1 by t integral from 0 to t R I0 squared sine squared omega t dt. This can be further written as 1 by t into I naught squared into R integral from 0 to t sine squared omega t is equal to 1 minus cos of 2 omega t by 2 dt, which is equal to I0 squared R multiplied by R divided by t into t minus sine of 2 omega t divided by 2 omega the whole divided by 2 from 0 to t. And if you substitute the values, you'll get I0 squared R by t into t minus sine of 2 into omega is equal to 2 pi by t into t minus, for 0 t will become 0 and sine 0 is 0, the whole divided by 2. Here you have a 2 omega, so this is equal to I0 squared into R by t into sine of 4 pi, these two t's get cancelled, So sine of 4 pi is 0, so it will become t, the whole divided by 2. So this is equal to I0 squared into R by 2. So what this expression shows that resistor is a dissipative element with a power dissipation of I0 squared multiplied by the resistance divided by 2. This should be noted that the resistor dissipates energy in the form of heat. Now let us move to the next component, which is the capacitor. For the capacitor, if you have a capacitor with capacitance C, and if you apply a voltage of Vft across it, then there will be a current Ift generated in it. So this current Ift can be written as C dVft by dt. Now if you assume Vft to be equal to V0 sine of omega t, then Ift becomes C V0, sorry, we take V0 sine of omega t, so it will become C V0 omega cos of omega t. Now if you write the expression for power dissipation, this will be equal to 1 by t integral 0 to t multiplied by the voltage, which is V0 sine omega t into C V0 omega cos of omega t dt. This we can write as V0 squared C omega by t integral 0 to t sine of omega t cos of omega t dt. It's equal to V0 squared C of omega by t integral 0 to t sine of 2 omega t by 2 dt. Now if you integrate, you will get V0 squared C omega by t minus cos of 2 omega t by 4 omega from 0 to t. So this will become V0 squared C omega by t minus cos of 2 into 2 pi by t into t minus, when you substitute 0, it will become cos 0. So cos 0 is 1, so it will become minus of minus 1. This whole divided by 4 omega. So this is cos 4 pi, which is equal to 1. So it will be minus 1 plus 1. So that is equal to 0. So the power dissipated in a capacitor is equal to 0. So power dissipated in a capacitor is 0. So we can conclude that capacitor is a storage element. One more thing that should be noticed here is the integral from 0 to t sine of omega t cos of omega t dt equal to 0. So sine of omega t and cos of omega t are orthogonal signals. So in any case, when you have a component with I of t orthogonal to V of t, then the power dissipated in the component equals 0. So keeping in mind this result, we will quickly derive the expression for the power dissipated in an inductor. Suppose you have an inductor with inductance L and a current I of t flows through it. Then the potential difference generated across the inductor V of t can be written as V of t equal to L di of t by dt. Now similarly what we have done in the earlier things, if you assume I of t equal to I0 sine of omega t, V of t becomes L I0 omega cos of omega t. Hence the power dissipated can be written as Pd equal to 1 by t integral 0 to t L I0 omega cos omega t I0 sine of omega t dt, which is equal to L I0 squared omega by t equals 0 to t sine of omega t in the cos of omega t dt. This term, which we have already proved, is equal to 0. So from this you can conclude that the power dissipated in an inductor is 0. So we can conclude that capacitors and inductors do not dissipate power. They are just storage elements. Thank you for watching the video. Please don't forget to subscribe.